Hello and welcome. My name's Dave Hicks, and today we're going to learn some chemistry. The topic, redox reactions. What we're going to learn in this lesson is, first of all, what is oxidation and reduction anyways? Then we'll learn how to identify the species that are being oxidized or reduced in a chemical reaction. Finally, I'll give you a couple special tips as a shortcut. So, first of all, oxidation and reduction. Sometimes we just call it by its short name, redox. These are reactions. Any reaction that transfers electrons during its process is referred to as a redox reaction. Now, the species that loses electrons, we say, is being oxidized, or that's undergoing oxidation. And the species that gains electrons, then, is being reduced, or we say it's undergoing reduction. Now, I got a couple mnemonic devices here for you to help you out. Oil rig has been a classic one that's been around for a while. Stands for oxidation, involves losing, and reduction involves gaining. Or, my personal favorite is Leo the lion goes grrr. And of course here we can see losing electrons is oxidation and gaining electrons is reduction. Somehow to connect up the L and the O and the G and the R so that you can remember this. Now, a couple of tips on recognizing a reaction as to whether it is a redox reaction. Any reaction that is involving any type of a pure element is definitely going to be a redox reaction. So this includes single replacement reactions, synthesis reactions, decompositions, combustions. All of these are redox reactions. Some notable ones that are not a part of this list are precipitate reactions and acid-base reactions. They generally are not redox reactions. And lastly, you can't have one without the other. Redox reactions are all about electrons. And if something's losing electrons, something else has to be gaining it. So, the big question that gets asked a lot in general chemistry classes is which species in the chemical reaction is being oxidized and which one's being reduced. So looking at this here, I have a synthesis reaction. I got nitrogen and hydrogen and it's turning into ammonia. Classic reaction there, right? Now, the first thing that we need to do, as I said down here, is we need to assign oxidation numbers. If you don't know how to assign oxidation numbers, I have a video in my collection that tells you how to assign oxidation numbers. You may want to go watch that one before you become confused by me assigning these oxidation numbers quickly. So we learned in that other video that the nitrogen here is a pure element, so it's going to have an oxidation number of 0. Hydrogen, it's also going to have an oxidation number of 0. But over here, we learned that hydrogens, they're always +1. And in this case, this particular nitrogen is going to be a -3. So I'm just assigning the oxidation numbers on both sides of my reaction. Remember that an oxidation number is just a way to kind of keep track of electrons so that we can see who's losing and who's gaining. So, checking this out, I can see that the nitrogen went from a 0 to a -3. And so definitely its oxidation number has changed there. For the other one, the hydrogen, I can see that it went from a 0 to a +1. So again, obviously, its oxidation number has changed. If the oxidation number changes, then electrons are being transferred. And down here, I have our last little thought with this so that we can identify which one's being oxidized, which one's being reduced. Oxidation, when you lose electrons, then overall it's going to become more positive. So in this case, the hydrogen went from 0 to +1, it became a +1, a more positive value. That means it's being oxidized. It must be losing electrons in order to become more positive. Likewise, reduction is gaining electrons, and if you gain electrons, it's going to become more negative. And here's our nitrogen. It went from a 0 to a -3, so this is definitely a more negative number. It must be gaining electrons here. All right, that's our first example. Let's try another one. I'll do one more. And then, as you can see, I have a couple more for you to do there, don't I? All right. So here's the next one, a combustion reaction. Let's go and assign the oxidation numbers for this combustion reaction. Hydrogen we know is +1. And since I have 4 +1s, that means my carbon here has to be a -4. Oxygen is a pure element, so it's going to be 0. On the other side over here, though, we can see oxygen is in a compound now. So now that it's in a compound, we know that oxygen is -2. Do that for both of them. Hydrogen is +1 when it's in a compound, and that balances out nicely with the 2 +1s and the -2. And then finally, this carbon over here, I have 2 -2s to the oxygen, so this carbon over here has to be a +4. Now again, I'm looking for things that have changed their oxidation numbers. The first one here I'm looking at is carbon. Carbon went from a -4 to a +4. So it's becoming more positive. That means the carbon is being oxidized. It's undergoing oxidation. It's losing electrons. And anytime there's a pure element in something, it's obviously going to be either oxidized or reduced, because the only time it's going to have 0 for its oxidation number is when it is a pure element. So over here on this side, doesn't matter which one you look at, both of those oxygens have gone from a 0 to a -2, and so they're gaining electrons because they became more negative. That means they're undergoing reduction. There are some odd cases where you might have one element that undergoes both oxidation and reduction at the same time. So on the other side, over on the other side, you may see it as both a more positive number and a more negative number. This is what they call a disproportionation reaction. And they're kind of rare, but I think they're neat when I see them come up. It's like, aha, it's a disproportionation reaction. All right. So let's see here. We'll get rid of this one, and I have a couple for you to do now. So I'll put these up here. The question is the same. Which one's being oxidized? Which one's being reduced? And why don't you go ahead and hit that pause button and work these out, and I'll be right here to help you out when you get finished. All right, how you doing? Easy? I bet you think it is. All we have to do is just assign the oxidation numbers to these. So let's do that quickly. I know that the oxidation number of these two, which are pure elements, are both going to be 0. And in this decomposition reaction over here on this side, I remember that halogens are going to be -1. And since I have 2 -1s, this copper must be a +2. It's also a monoatomic ion, which is going to be its charge, which would be copper 2 here in this case. So I went from -1 to 0. That looks like it became more positive. So in this case, it looks like, whoops, -1 to 0. Do that again. Here I went from -1 to 0, and it became more positive. So since it's becoming more positive, I'm going to assume that it is losing electrons, and that's oxidation. The copper went from +2 to a 0, so it's becoming more negative. Therefore, it must be gaining electrons or undergoing reduction. And then down here, for the last one, this is a single replacement reaction involving halogens. We know that this chlorine's got to be a 0 because it is a pure element, and this bromine's got to be a 0 for the same reason. Potassium is a monoatomic ion, so it's going to be equal to its charge. And so is bromine and chlorine, both monoatomic ions, plus they're halogens, so that they tend to be -1s. And finally, we just have to look to see what has done its change, right? So here I have chlorine, and chlorine went from a 0 to a -1, more negative, reduction. And bromine went from a -1 to a 0, more positive, oxidation. How'd you do? Not so bad, huh? Finally, I got a couple little tips for you. This is from long time knowing chemistry. And I just happen to know where these two words came from. Oxidation came from the idea that metals tend to oxidize when they're in the presence of oxygen, right? So anything that's gaining oxygen, you can bet, is being oxidized. So check it out here. I got carbon and hydrogen. Here's carbon, and on the other side I have carbon with oxygen. And here's hydrogen, and over here I have hydrogen with oxygen. We learned when we did this one that the carbon here was being oxidized. See? It's reacting with oxygen. Down here, for reduction, that's an old mining term. It means to purify a metal. And so anytime you see a metal that has been purified on the product side, that means it's being reduced. And that's where the term comes from. Now, of course, if you see these happen in opposite directions, so I started with a pure metal and it ends up in a compound, then that's being oxidized because that's the opposite, right? And if you see something that's losing oxygen along the way, then that means that's being reduced because it's the opposite of oxidation. All right. Well, I hope you're feeling more confident with oxidation and reduction reactions. And join me next time here with Chemistry with Dave Hicks.